Welcome to career guidance section. Within that interview preparation session. So welcome to 360-degree TMG. So let's start with analysis. Ability. Explain that. Nothing but listed events by total number of events. We all know. How do you explain joint probability? Probability. So it is a probability to events example, we all know that probability of an email being spam when one particular word in it, and there's a chance that the events are nothing but the email being spam and the email is having the word. Let it be anything, like it could be any word here. So there is nothing but two events are occurring at the same time. You call it as joint probability. Then probability distribution then. Distribution. What are the inferences we are getting as a part of probability distribution? Probability distribution is a function probabilities different possible outcomes in an experiment. We have random variable on x-axis. The one we have on the y-axis, associated probabilities. Right? Uh, Probability distribution. Word random variable, definitely we need to understand what is a random variable, right? Any variable which is not following any pattern is called as random variable. So it is not following any pattern means you have different fluctuations in your data, different like the minimum value and the maximum value. If you calculate, there could be any number between those two values. Like it is not like continuously same number popping up. It is different numbers popping and it is a different pattern being followed. So how many types of random variables are there? Two types of random variables are there. One is discrete random variable and other is continuous random variable. So a discrete random variable is a variable that has countable values. Mostly we can say that non-negative numbers, maybe the number of students, number of heads when you flip a coin, and students, number of students appearing for an exam, right? Number of different color or how many colors of marbles are present in a jar, right? All these come under discrete random variable. So what do you mean by continuous random variable? So a continuous random variable is a variable with a set of possible values that is infinite and it is uncountable. Maybe it is the height of a student, weight of a student in a class, right? Distance between two planets, distance between the classes. All these are the examples of your continuous random variable. So, continuation of this question will be, if at all you have probability distribution, what are the classifications of probability distribution? Right? What are the classifications of distribution? Classifications here. So generally, when you have discrete random variable, you will have discrete probability distribution. When you are having the underlying random variable is continuous, you have continuous probability distribution. Right? This one and this one. Continuous means you have continuous, otherwise it is discrete. Okay. One is random variable. It is discrete probability distribution. And random variable as discontinuous probability distribution. But what do you mean by data types? This term data types. Programming, when we talk about this, right? We can say that a data type application is which values or a value, a variable, and what type of operations. We can say math operations or relational operations or operations applied causing any error. Nothing but you explain it as a data types. But if I would like to know from you people, what are the classification of data types with respect to exclusively with respect to statistics? How do you do the classification here? What are the classifications of data types in statistics? Yeah, what are the classifications in stats? You call it as qualitative and quantitative data types, right? Qualitative data, right? Yeah, that is different, that you are again further classifying into different measurement levels, that is nominal, ordinal, interval, and ratio data type. These are further classified into those two. Okay. Now, if ask you what is the difference between nominal and ordinal data? And nominal data. Name, right? Product ID, product name. All these are your examples of nominal data where you don't get any much information, any much insights out of your data collected. State names, country names, merely just a label. Maybe languages spoken by a person, your jersey numbers of the football players, cricket players. All these are your nominal data type. But what is this ordinal data? Ordinal data is something where it maintains some order, right? So if at all you are trying to work, or it is like it will be a grade, right? Where you have some order being maintained, roll numbers, shirt size, egg size, ranks of a competition, right? Educational background of a person. All these are your ordinal data type. So if it is nominal, it is just a label. If it is ordinal, order is maintained. So depending upon this only, we are trying to find out. If we have to know even the difference between, or how is interval data different from ratio. Data different from ratio data type. Right? Right? Interval data is subjective. It is a local measure. Something we can say is perception. Right? Interval is subjective. It is a local measure and it is a perception regarding particular object, regarding the person, regarding an institute, anything, regarding a Coke or tea or any product. It is a perception here, right? But when it comes to ratio, it is objective in nature, right? It is a relative comparison or relative measure, right? And it is universally compared, universally same. Its measure is same across the globe. Same across the globe. But there is one more difference between them. There is a concept of absolute zero. So absolute zero means true absence of a value. Right? We don't have any absolute zero here. There is no zero here. Right? If I say temperature, right? 0 degrees centigrade. Centigrade, it has, and it means that yes, it is cool or hot, something like that. Some meaning is there. But if I say measurement of heat is 0, it means that there is no heat. Where these two differ mostly like that, and most preferred data, the most preferred data here is this. The least preferred data is your nominal data. Because why are we saying least preferred? Nothing much is inferred from the nominal data, and the ratio data is only mostly preferred because it is same across the globe. Understand by categorical data. Categorical data. Data. Type where we cannot perform calculations. Right? Into groups blood groups, it could be flavor of ice creams, the types of rocks, right? It is basically your qualitative data. Right? It has a, we can say it is qualitative, it is fixed set of values. It is non-numeric data. Anything, right? Flavor of ice cream, flavor of ice creams, and any group, if you talk about. Okay. What are the various types of analytics? We missed out this question. Types of analytics. Right? Descriptive. So what are we understanding with respect to descriptive here? Usually descriptive can be combined with diagnostic also, but descriptive describes about the data. Like when we are ill, when we reach out to doctor, we describe, right, that we are ill, we are suffering from fever, headache, cold. You're describing things. It's nothing but your descriptive statistics. And when you're describing what happened, and then you diagnose. He has to diagnose you, the patient, right? He will diagnose you, right? Why that something happened? Why that something happened? So generally, in few books, in few resources where we check, they combine these two and they put it into one, and they say that there are three types of analytics, right? It's like, we'll have any X-ray report or ECG report, any report we take, blood test report, what could be any corona test report. We can just say why that something happened. He'll just see and he'll help us to know, and he will predict what will be the future. It is nothing but your predictive analytics. You'll be given some things, explain to you that see this is going to happen. You are going to predict, right? What is likely to happen? It means that some proactive action can be taken, right? Advice which is taken from at this particular stage is predictive. And finally, prescriptive analytics. What is to be done? What is to be done? Here it is a major part, decision making. If the decision making is done by the device, it is your AI driven object. Right now, the doctor is giving you decision is taken by the doctor. If it is taken by a device itself, then it is a smart device and it is nothing but an AI driven application or object or product. Right? These are the four stages of analytics. Now you should understand even inferential statistics. Inferential statistics. As a part of inferential statistics, so it is the entire of deriving results from population, right? From the population, we are just taking, we take subset of data. We're taking some subset of data, and whatever results you are getting, what you call those results as sample statistics, right? We are picking the subset of data, you are performing analysis and try to get some insights out of it. Okay, that is the main aim here, right? So what is it happening here? The results we get are generalized. These are generalized, assuming that this is important, right? The results will hold good for even population. The results will hold good for population also, right? So the entire process is nothing but you call it as a sampling funnel concept also, right? They may ask you what is sampling funnel also. The subset of a population is sample. The results you get, right? The results you get on sample are called as sample statistics, right? The results you get on sample are called sample statistics. Hence, we are calling it as, hence the name, or hence we call it as inferences is what we are getting. So it is inferential statistics. So you may get a couple of questions from here, like what is sampling funnel? How do you derive a sample? What should be a sample size? What should be a sampling frame? What are the different sampling techniques? Right? Yeah. What is the sampling frame now? What is sampling frame? To derive a sample, to derive a sample from a population, there is a procedure, which is nothing but a sampling funnel, right? You have your population, you have your sampling frame, then technique, then it is sample. It's like a funnel shape. Right? Out of that total process, now you want to get a sample, you are applying a unique condition, right? So what we can say, whenever we are working with, whenever we work with the population, right? We take a subset of it. We take a subset, okay, of the population by applying a unique condition, right? By applying a unique condition on it to work upon, or yeah, to work, right? There should be a way, right, to identify each data point uniquely. So only then we can define some probability here. So this has to be done on sampling frame. This is a condition we apply on the data. For example, if you are taking elections and I want to conduct some exit poll survey, I have population means entire country's population would be how much? Some crores. Out of that, how can I pick a sample? I should eliminate, filter out few people, like how organizations filter out few profiles which are not required for them. So not all the people are important for us because it's a combination of different age groups and not all are eligible for vote. They should be a citizen of our country. They should be crossing the age of 18. And these are a few conditions you pose on that particular population here, right? So from this population, you are getting a subset if you apply this unique condition, like they should have voter ID card, they should have Aadhaar card, anything. From this becomes your applying condition on population, unique condition. That condition is nothing but sampling frame. So this is your population. You are getting this circle. This is being your sample actually, right? But directly this much big sample, you cannot have it. You cannot work on it. Right? You can use different sampling techniques as your third step, right? You take apply different techniques, sampling techniques to pick your sample. So my next question is also that what are the different sampling techniques? So this is very important question because it keeps on changing when you have Y being continuous, Y being categorical. List all the different sampling techniques. We have an option here to use. First thing, mostly it's familiar and broadly as probability sampling and non-probability sampling. Right? Non-probability sampling. These are the broader classifications of your sampling techniques. The difference lies between these two is whether the sample selection is happening or it is based on randomization or not. With randomization, every element, every person or every unit, every observation is getting equal chance to be picked up and to be a part of the sample for the study, right? So now how do you explain this probability sampling and what are its types? Means yes, the sampling technique which uses randomization to make sure that every element of your population or sample will get sorry, not sample, a population gets an equal chance to be a part of your selected sample, right? So the mostly you, if at all you talk about the types of probability sampling, okay. So probability sampling is nothing but it uses randomization. Okay. In selection process. Okay. So what is a type of probability sampling here? First and most famous and the default technique here is your SRS technique. The simple random sampling is the first technique we can take. Every element has an equal chance here. Every element has an equal chance of being selected, right? Chance of being selected or to be a part of your sample, right? Just like we are not giving any priority to anyone. Then comes your stratified sampling. When you go for stratified sampling, so this mostly for categorical data we can say, or whenever you have unusual like different classes are there, and it's imbalanced data set, right? So it is divides the population or the elements of population. Divides the elements of the population into small subgroups. Right? Those subgroups are nothing but you call them as strata based on the similarity. So in such a way that we can say that the elements within a group are homogeneous right, and hetero among the other. Or the heterogeneous among the other subgroups. Right? So mostly imbalanced data set means our familiar data set, right? We have a flower, which is an iris flower. It is divided into 3 different species. You can have a setosa species, versicolor species, and virginica. Right? So when you do a random sampling, simple random sampling, right? Maybe the number of setosa, number of versicolor, number of virginica species, or its attributes, its variables, whatever you have collected, they may not come appropriately in your train data and in your test data. Suppose usually these are 50, 50, 50, assume. If you do simple random sampling, your training data may have 30 of your setosa, 20 of your versicolor, 10 of your virginica, suppose. So what happens when you go for test? How much? 50 plus 10, 60 are done, no? So I can make it, improve it, 20, 20, 20. Here, the rest of them are in your test data. So what is happening? Less training is happening on these two. But when you come to test, more testing is happening on that. Less training, more testing. It's not preferred. So you have to go for stratified sampling. You have an argument. You have to make it as true, stratified equal to true. So it will take such a way that setosa 70% of 50, versicolor 70% of 50, virginica 70% of 50. 70% of 50 data points will be in your training data. Leftover 30% of 50 data points, the data points means observations. 30% of 50 observations, 30% of versicolor 50 observations, setosa, versi, virginica. They are taken, they are kept in test. This is what is going to happen if you have imbalanced data sets, or balanced also sometimes this will work, but mostly if it is a classification technique, this is preferred. Right? If it is imbalanced also, you go for this. If it is categorical also, you check if equal proportion are there here. You try to make equal proportions in your train data and test data. Otherwise, we will enter into some we need to, again, once the results come out, we have to spend a lot of time. Do again this pre-processing technique. Okay. This is most preferred one. Clustering sampling, cluster sampling. So now you are dividing into the name cluster, right? It is divided into clusters. So one cluster with age group, one cluster with sex, a group, one cluster with location, right? So you're dividing your entire population into clusters or sections, and then the clusters are randomly selected. All the elements of the cluster are used for sampling. Right? It's up to us now. How do you want to make the cluster? On what variables? Okay, so let me make it into a small statement here. So entire population is for example, you have age, you can have location, income, whatever. Okay. Now, non-probability sampling techniques. What is non-probability? It does not rely on randomization. It does not rely on randomization, right? Here, the outcome of your sampling will be biased results. Right? You also call it as non-random sampling. But there are few types here with respect to this. What are the types here? The first type is convenience sample. Sampling. Okay. So now the name convenience. So samples are selected based on the availability. You're selecting sample based on the availability of the sample. So this is used when the availability of sample is very, very rare. You did not get to collect any data, anything. So based on the convenience, the samples are selected. So when you are doing a research, you have started your research, right? You did not get any clue or anything, right? At the initial stage, whatever is available, conveniently available, you take that as sample and you work. Okay? That is the first one. Then you have purposive sampling. So this is based on the intention or it is based on the purpose of study. Right? It is based on the purpose of the study. Only those elements will be selected from the population which are best for you. Right? Which are best for you. So if you want to understand the thought process of the people who are interested, like for doing PhD or they're doing their master's degree, right? You only take those people for your analysis. Then you have quota sampling. What is this quota sampling here? It depends on some preset standard. So it selects the representative sample from the population, right? Or the proportion of characteristics, some quota. Like, if our population is having 45% females and 55% males, then our sample should reflect the same percentage of females and males, right? That is your quota sampling.
Then it is your snowball sampling. So it is used in situations where the population is completely unknown and rare. Therefore, we'll take up the help of the first element, someone we catch hold of, like detectives hold of, right? Then hold one person, whatever he reveals from that, again, they analyze something, they pick the other person. To complete the entire, to close that particular case, they pick one after the other, one after the other, like improving the snowball. When we start playing with the snowball, how it will be? We'll take a small uh, sample. From that, you again add so much of snow that the ball size would improve. The sampling size also will improve. Right? Not all will respond, that we know. So this is a referral technique, increasing the size of the population just like a snowball. So you also call it as a referral sampling here. Okay. Now, so these are the few sampling techniques. Probability and non-probability. Okay. Now, yeah. How do you explain the first business moment? First business moment. We'll take this question and we'll stop for the day. Yeah. What does it actually? It is a measure of central tendency. It's a measure of central tendency. It captures the characteristics of your data. Right? So the mean is a representative value here. Right? Of the entire data. And that is your average. Right? So here your mean is acting like a balance. Right? Mean is acting like a balance. So what does it capture? It is nothing but your center. So mean, median, mode. Three are there. But if I say first business moment decision, I refer to only mean. Just because you have outliers and all that, we are saying median, and if it is categorical data, we are saying that it is mode. Right? Right. So this is the first moment business decision. Then what you can do? We have our friend here, outliers. What are outliers? How do you explain outliers? They are the extreme values in your data. They are extreme values in your data which do not follow Right? Any other properties? Like your restroom, your data, right? So we can say that this is a value which is pulled away from majority of the data, or I can say concentration of the data. Right? From the majority of the data. Right? Now, how do you explain an expected value? What is an expected value? How to explain this? Expected value? It is nothing but definitely this is also your mean, but you call it as expected mean, right? When we have uncertain behavior with our data, right? So it's average by considering when we have uncertainty in data,
When we have uncertainty in data, we have then chance associated each outcome is calculated, right? So that's why this is also called as weighted average, right? This is called as weighted average.
Yes, I have just joined in and I'll be waiting until you say me. Hello.
Average, but it is a weighted average. Why? Because the values are not certain and they are not static. They are always they are volatile, and you are calculating something when one particular outcome is infinite number of times. When you toss a coin 10 times, you can't say whether it is 5 times heads and 5 times toss, 5 times tails. If you do it for 20 times, if you do it for 50 times, for infinity number of times, there's a possibility that 50% times heads may come, 50% times tails may come. Right? That is what you are expecting out of this particular outcome. When such situation occurs, when you are doing it for a long run, you don't do mean, you call it as expected mean or expected value. Okay. So thank you all for joining the session once again, and thank you. Let's connect next week. Please proceed with the next session. Thank you.